In this video, I would like to show you how to quickly map Modbus TCP and RTU meter registers to BACnet objects using the BLC-MBUS-250 Gateway by mikolab. The entire process from adding meters and reading their registers to viewing mapped data on the BACnet workstation will be presented. The Modbus RTU and TCP to BACnet tabs are used to configure the mapping of Modbus meter registers to BACnet objects. This process will be demonstrated using the Modbus RTU tab with notes on differences found in the Modbus TCP tab. The window operates in three modes: config, used for configuring the mapping of Modbus meters and registers to BACnet objects; reading, enables cyclic mapping of previously configured Modbus registers to BACnet objects; virtual COM, allows external software to communicate with Modbus. This mode is available only in the Modbus RTU tab. The first step is to add new Modbus meters to the list. To do this, click the plus icon and enter the required meter parameters. For a Modbus RTU meter, you need to specify the following: device address, name, used to distinguish between devices and default BACnet objects names; baud rate, data bits, parity, and stop bits. For a Modbus TCP meter, in addition to the address and name, you must also provide IP address and port number. After adding a new meter to the list, it becomes visible in the meter table. The plus icon in the status column indicates that it is a newly added meter. The blue section displays the previously entered name and address of the meter. The yellow section of the table provides information about communication with the meter. For each device, you can individually configure the transmission parameters, reading interval, and possibly other advanced Modbus query parameters for reading non-standard meters. For example, some meters can be configured to read every 15 minutes, while others might be set to every 6 hours with different baud rates. The green section contains data for the BACnet binary value object representing the meter, which will be filled in the next step. The red section shows the number of mapped registers. The list icon redirects you to the meter register list, which will be explained in the following steps. Newly added meters are not automatically mapped to BACnet objects. To create a meter object, select from the BACnet menu and then choose Create Meter Object. For the gateway to map the meter registers, you need to create a binary value object with an instance number in the range of 1 to 250. You can allow for automatic selection of a free instance or specify it manually. If more than one meter is selected, the entered instance number will be the starting sequence number. After creating the objects, the green section of the table will be filled. The reference contains the type and instance of the object, while the name contains the BACnet object name. Names are generated automatically based on a previously entered meter name and naming scheme. Separate schemes are available for objects representing the BACnet meter and for objects representing meter registers. The default scheme can be edited in the BACnet menu under Default Naming Rules. The red section of the table provides information about the mapped registers of the Modbus device and includes a button to open the register window. Modbus devices have registers that can be accessed using various types of functions. To save time when reading multiple registers, it is possible to request a group of consecutive registers instead of sending multiple individual requests. This set of registers is referred to as a group in the interface, and each individual data record within the group is called a register. You will often find groups of registers documented in the technical manual for your meter. For example, in the Counties E04 meter documentation, both groups and individual registers are listed. In the BLC-MBUS Gateway, a register can only be read if it is part of a group, so you must create the group first. To do this, select Create New from the Groups menu. To add a new group, you need to define the Modbus function, the starting address, and the number of 16-bit registers in the group. In the Counties documentation, for instance, there is a group starting at address 51,280 that contains 36 registers. I'll enter this data into the form, confirm, and wait for the meter's response. Once the data is received, a table displays the content of all the registers, represented in different data types and sizes. This helps determine the appropriate data type for each register. By default, the table shows the most commonly used data types, but you can view additional types by selecting them from the list. For data types larger than 16 bits, the address column displays the starting address of the first 16-bit register for that data type. According to the meter documentation, the voltage is stored in the register at address 51,284. The data type is unsigned 16-bit, and the value must be divided by 100. In the form, I'll select the required data type for this address and assign a name to it. The value of register is correct because, after dividing by 100, it will be around 230 volts. Calculation rules will be set later when creating the BACnet object in the next step. After saving, the group appears in the table along with the defined register. To add another register from the group, select the group and click Edit in the Groups menu. The registers will be reloaded, allowing you to modify them as needed. I'll add a register containing frequency data by checking the address and data type in the documentation, then selecting it in the form. Now the group contains two defined registers. Registers are not automatically mapped to BACnet objects. To perform this mapping, go to the BACnet menu and click Create BACnet Object. Here you can specify the BACnet object type, unit, and instance, or use the auto mode. This is also where you define any calculations needed before mapping values to BACnet. For example, according to the documentation, the unit is volts, and the value should be divided by 100. After completing these steps, the first BACnet object is created, with its name derived from the previously entered register description. I'll repeat the process for the second register. Now I'll switch to the BACnet workstation, where you can see the created BACnet objects, one binary value representing the meter, and two analog value objects representing the Modbus registers. Initially, their values are 0 because the system is in configuration mode. I'll change the mode to running and check if the meter has been successfully read, which is indicated by a green check mark. Now you can see the values being updated in BACnet, refreshed at the specified interval. After verifying the correct mapping of the Modbus meter registers, we can transfer the configuration to another meter. This feature allows for quick configuration of meters of the same type. To start, I return to the Gateway page and switch it to config mode. First, I need to add the new meter to the list and create a binary value object to represent it. Next, I navigate to the Replication menu. The copy and paste options enable copying configurations between meters connected to the same gateway. Alternatively, the copy to file and paste from file options allow transferring configurations between meters connected to different gateway devices. Let me demonstrate the first method. I select the meter which configuration needs to be copied and choose Copy in Replication menu. You will notice a copy icon appears in Status column. Then I select the meters to which we want the configuration transferred and click Paste in Replication menu. After this operation, the new meter will have the exact same registers mapped to the same BACnet objects. We can see the newly created binary value object for the meter along with the mapped registers in BACnet objects. Now let's confirm whether the mapping has been correctly applied to the copied meter. On the BACnet workstation, we can see that the same registers are currently visible 2 times, one for each meter. However, the new meter has 0 values everywhere. That's because we are still in configuration mode. You will need to return to the Gateway page and set the mode to reading. The meters will then be read in sequence and the BACnet values will be updated, which can be seen on the BACnet workstation. We have finished mapping the Modbus meter registers to BACnet objects. Now the Gateway will map the registers according to the set interval. To learn about other features of the Gateway, we invite you to other materials. Thank you.